Hi, welcome to Wisecat. Okay, this is the start of a series on SSH, and hopefully there'll be a few more videos that actually talk about SSH and how to do SSH key authentication, and also how to harden your server. Make sure that your server is difficult to be hacked and also easy for you to access. So that's kind of the goals of SSH security. So let's get straight into it and talk about SSH key authentication. So you might know SSH already as the protocol that we use to connect to our servers, right? We log into the servers using SSH. But the basic form of SSH is that we use passwords, and they're problematic. And the reason why, and I'm going to shrink myself down. The reason why they're problematic is that passwords in particular are very easily brute forced, right? You can just go SSH user at server and then try to log into the server, guess the password, and if the password is something like President Scrooge has on his luggage, 1, 2, 3, 4, 5, then they're very easy to brute force. Now the thing is that also passwords, in order to be input manually, they tend to be short in length. So, maximum is probably 20 characters or something like that. But if you're logging into your server and you only have a 20-character password, how many times does a robot have to actually try to guess that password before it can brute force it and guess it? So the short length in passwords is inherent in passwords because they need to be typed. That's actually another weakness. They're also very difficult to input because every time you SSH into a server, if you're using password authentication, you have to input that password as soon as you finish typing your SSH command. And you might not remember them. Ideally, you're using a password manager, and you might actually copy paste from the password manager or something like that. That makes it a little bit easier, but it's still a pain in the butt. I mean, you can, if you could just type in your SSH command and be done, that would be better, wouldn't it? And that's what key authentication can do for you. And the last point that I've got here is that passwords tend not to work so well with automation or scripts. So if you have a script that you want to run on, say, 7 servers, then every time that script wants to SSH into each different server, you've got to insert a password. You've got to use a switch on your SSH command or something to pass the password to the script, and that's not so great. I mean, it'd be easier if the computer could just access the server and do what it's got to do. So these are the problems, some of the problems anyway, with passwords. Makes them less secure and less convenient. So actually, SSH key authentication is much easier once it's set up. But setting it up means actually we have to understand what it is. And so in SSH key authentication, we actually have what's called asymmetric key encryption. What does that mean? Well, it means that we have a public key and we also have a private key. And we have these two different keys, one's public, one's private, and we keep them separate. Why do we call one public and one private? Well, one we share with the world, and the other one we keep completely secret. And here, and this will probably come up again, but quack quack, Ducky's win tip of the day is that a machine's private key should never leave that machine. And yes, Ducky is very serious when he says never. All right? Never, ever, ever should it leave the machine. And actually, this is a problem that I recently saw on a friend's Mac, where the Mac automatically synced the private key into the iCloud, and so the same private key was actually available on all these different Mac and Apple devices, which sounds incredibly convenient for one, but that means that any one of those devices gets compromised, gets stolen, for example, and then that's it. The keys to all the castles are completely done, and the only way to revoke it would be to revoke permission for every device to access the server. That's not great. So anyway, back to it. So basically, we're going to create or generate two keys, a public key and a private key. And the cool thing about a public key, private key pair is that when you take your message, you can then use the public key to encrypt that message. So we're using one key to encrypt the message, and bang, there we go. Now we've got an encrypted message. We can't read it because it doesn't make any sense because it's encrypted with the public key. Now the only key in the world that can decrypt that is this private key, the other half of the two key pair, and that can decrypt the message. Now, another really cool thing is that this can work in reverse as well. So you can take a message, encrypt it with the private key, and then you can use that private key's corresponding public key to decrypt it and make the message. Right? Now, what about, can't you decrypt with a public key? No, these are not reversible. So if you take a message, encrypt it with the public key, and then try to decrypt that same message with the same public key, you get junk out. You don't get the actual message out. The original message it's not going to work. So when I move my head, yeah, public key cannot decrypt with public key. And likewise, private key, you take the message, encrypt with the private key, and then you try to decrypt that with the private key. Yeah, no soup for you. You cannot decrypt the private key encrypted message with the same private key. So only the private key encrypted message can be encrypted with the public key, and only the public key message can be encrypted with the private key. So that means if somebody's out there and they want to send you a message and they want to make sure that you're the only person who can ever read that message, well, one way they can do it is they can encrypt it with the public key, and then you're the only one who can read it because you're the only one who has the private key. Remember, you obeyed Ducky, you didn't upset Rubber Ducky, and you've never shared that private key. It's never left your machine. So that machine that has this private key is the only machine in the world that can decrypt that message. Now, this is really, really useful when it comes to the server. So what we can do is we can use this private key thing. So we can say, okay, I have a message, I'm encrypting that message and sent that to you. You have the public key, so you can decrypt the message. So what we're going to do is we're going to take this public key and we're going to put that inside our server, right? And the problem we're trying to solve here is, right, we want to tell the server, hey, this person is authorized to access this server. So this server needs a way to know that you're you. And what it's going to do is it's going to use this public key to say, okay, if you can encrypt a message that I can see with the public key, then that proves that you have the private key and are authorized. Okay, so we do that. We take our message, we try to SSH into the server, we take a message, we encrypt it, and we send that off to the server. And the server takes a look at it and says, okay, I'm going to decrypt this message. What do I see? Do I see junk, or do I see an actual message at the end? And if I do send see the message at the end, then we say, yay, this is great, you are authenticated. All right? Okay, so that's the theory behind how it works. And yeah, I've sort of oversimplified a little bit, but don't worry about that too much, because what I really want to get down to is how we actually do this on our service. So I've got myself open a little terminal window here, and right now I don't have any keys. So if I want to SSH into my Vagrant server that I've built here, all right, I do SSH Vagrant at vagrant.wisecode.net. I do that. It says, okay, I don't have host authentication, so I just got to type in yes to say it's the first time I've logged in. Oh, and that's another thing is that if you're using password-based authentication, you could log into the wrong server. And then if you log into the wrong server, then you've given that wrong server your password. That is actually an attack out there in the wild that does actually happen. So anyway, this one here, I've got my, it's asking me for my password. I know that this is, in fact, the server that I'm trying to log into. So I enter my password, and bang, I have done my first ever login into this server. Right? So, yay. I've got that here, and I can do that. Now, actually, this being a Vagrant server, it does actually have its own Vagrant-based SSH key already installed. Vagrant actually does that by default. So if I look in here and look at, oh, I don't even have a htop installed. But anyway, ls-la will actually list this directory. And we can see that I have this last entry here, which is the SSH directory. Now, that's where the SSH configuration goes for this user, which is the Vagrant user, right? So let's have a look in that directory and see what's in there. Right, if we look in here, what we can see is we see this file called authorized keys. Now this is where the public keys of anyone who's authorized goes. Right? So you stick your public key in there. Remember, we're not sticking our private key in there. You do not let that private key out of your machine. We do not want private keys in there. We want public keys in there. So let's have a look at that. Cat authorized keys. And if we look in there, we can see here I have a key. It's in the it's of the type ED25519, which is becoming the default, and it should, if it's not the default on your machine, then you should just use the -T. I will cover that in a moment. But this is basically saying that this vagrant default key is authorized to access this machine. If I just go actually nano authorized keys, bang, I can actually just add a second key or a third key or a fourth key on new lines, you know, one per line. And I can add as many as I want. I'm not restricted by adding keys. So anyway, let's just exit out of that. And let's go back to our main machine. So we're currently on the bookworm, which is, it's a Debian vagrant. So yeah, that's just called bookworm. But let's go back to Mammoth. This is Adamant Mammoth. This is me. I'm on my home machine here. So let's get a key, right? Let's get a key. So what we want to do next is we want to get a key. How do you make a key? Well, there's a tool called SSH. And, you know, we really should call it shh. Wouldn't it be better? Shh. But anyway, SSH, we've missed the opportunity. Everybody calls it SSH. I don't know why. Anyway, SSH-Keygen. Now, this by itself will generate a key, and it's going to put it in a default location, and it'll probably generate RSA keys. Let's see what happens. Just SSH Keygen like that. Okay, so we can see it's generating a public and private RSA key pair. RSA is kind of the old way of doing it, and as I said just before when we looked, the vagrant key was ED25519, which is a better, more modern place. Anyway, this is going to save it to this default location, which means that SSH will know to use this key by default. So if you SSH in, you don't actually have to tell the SSH what identity file to use. It's going to just save it in this default location. So I'm just going to hit enter there to accept this default. And I can enter a passphrase, so you can actually passphrase encrypt this RSA key so that if somebody wants to use it, they're going to also have to add another password. You can do that for additional security if you do. I'm not going to do that. I'm just going to leave it empty. And enter the same empty password again. I'll just hit enter again. And there we go. And I've got some RSA random key art here, which is kind of cute. Hey, we got a Bob in there. Yay. Anyway, and a Bobo. Yeah, okay, cool. So anyway, what has that done? Well, on my computer, what that has done is that's made a .ssh directory. Now, remember, on the server, we saw that there was an authorized key files. Well, what have we got in here? Well, we don't have... Oh, I've got a known hosts old file there for some reason. Yeah, okay, whatever. Anyway, these are the two that we've actually generated. The known hosts file here, this basically is saying, okay, we know now know who the fingerprint for the vagrant server is. Right? And the reason this is important is because this means that when I go to SSH in to vagrant@wisecat.net, it recognizes this vagrant.wisecat.net server from before, and if that signature has changed, then it says, hey, something, you'll get a message that actually says, this doesn't look like the server that we're used to. Somebody might be eavesdropping, somebody might be doing something really bad, so proceed with caution. And if you see that message, don't ignore it. Heed that message, because that could well be a hacker trying to steal your password for your server. And if you're doing password authentication, it really sucks when you do get duped by that. So, you know, and keys can help prevent that. But anyway, that's what known host does. But here are the two that we've actually just generated. This is IDRSA. That's the private key. And IDRSA.pub, that's the public key. So if I have a look at them, right? Oh, cat ID RSA. This is the private key. Now, okay, by the way, I'm going to shrink that down, but I'm also going to delete this private key afterwards. I'm not actually going to use it. I'm just showing you that this is what it looks like. An open SSH private key. This is an RSA private key. Bunch of key text here. You can see that's bigger than any password you're going to come up with. And down here at the bottom end, open SSH private key. Now this private key corresponds with the public key, which is much shorter, and it's this. And you can see that it's prefixed with SSH RSA, and at the tail it says whose key this belongs to. And so this is Adam at Mammoth's RSA public key. And so what we can do now, if we want to authorize this key, is we take the public key. Remember, we're going to put the public key on the server. I'm going to copy that. And now I can SSH into the server using the password for one last time, right? And now I can go nano, okay, .ssh/authorize keys. And as this user, I can just paste this in here, right? There's our key. It starts with SSH RSA, ends with Adam at Mammoth. That's my key, bang. And that is it, we're done. Well, what have we done? Well, watch what happens next time I try to log in. So you see that last time I tried to log in, I type in ssh-keygen@wisecast.net, and it asked me for a password, right? Right? Well, let's log out, and now let's try to log in one more time. And the magic of keys gets me straight in. No password required. Pretty cool, huh? And the thing is that your scripts can also get in like this. So they don't need a password. You don't need to give a password to the scripts. So that's really convenient. But what happens if, say, you know, okay, I want to deny Adam at Mammoth. He was a naughty boy. He hacked me. Okay, I want to deny him access to the server again. Yoink. I've taken that out, and now if we go back to SSH, try to log in again. Now it's going to ask me for a password again. Okay, now there's a way to switch this password thing off. We'll get to that in a moment. But let's first of all, let's try making another key, right? We're going to do SSH Keygen again, but we're going to make one of those cool ones, the ED25519 ones. And that's the type of key that we're going to build. So we're going to just, after our SSH Keygen command, we're going to add in -T for type and ED25519. Now it's making a private and public-private key pair for ED25519. That's what it's doing. And it's going to save that to the default location there again as well. Right? No passphrase again. And then I've got some more ED25519 with SHA-256, and this is what it looks like. And yeah, I got new art. Yay, pretty. All right, so now if I look in this directory, now we can see that we've got still got our ID RSA IDs here, but we've also got this new one here, ID ED25519 .pub one. So now if we SSH in, still asking for a password. Well, we could go in, we could log in. By the way, I'm going to delete those RSA ones. RMID R _R. Yeah, I couldn't be bothered typing the rest. All right, so they're gone. All right, now I've just got the ED25519 ones. All right, so I could just go in. Remember what we did before was we SSH'd in, we enter the password, PASSWORD, don't use that password. And I can nano the SSH keys and I can paste the key in there. You know, remember I said this was going to be easy. Well, there is an easier way, and there's actually a second easier way as well. So I'm going to teach you that right now. So next time we log in, instead of typing in SSH, let's do SSH -copy -ID. And what this will do is it'll make a connection. It'll ask me for the password so that it can make a connection, and SSH copy ID will copy my ID, my public key into the server, and put it in the right place automatically. Isn't that great? All right, so let's try it. Boom, we go with that. It's asking me for the password. Okay, password time. Last time, PASSWORD. And there we go. Now it says number of keys added, 3. So it's actually added a few different ones. Yeah, but anyway, I can now log in with SSH Vagrant and Vagrant, blah, 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 and check to make sure that only the keys you wanted are added. So it's actually telling me it's added 3 keys. Maybe you don't want all of them, so you should go and check. All right, so what can we do? We can SSH in. Boom, no password required. We got straight in. And let's go and nano that authorized keys file again, and we can see what was added. What was added? There's an RSA one for Adamant Mammoth. There's another RSA one for Adamant Mammoth. I guess I've got a couple of other ones in other default locations. But this is the one we built just recently, the ED255191, and you can see it's a lot shorter, and that's the one that we want. So I can exit that one, and now only one of the keys is in there. So I've just revoked permission, revoked authorization for 2 of the keys. Log out, log back in, check that it works. Now checking that it works is very important because of what is the next step in this process. So to recap until now, the story so far is that we have created ourselves a public and private key pair, and we've authorized that key on the server. Now, before you go any further, you want to do this. If you're doing this on a real production server, for example, you want to make sure that you've got multiple keys for multiple devices authorized on your server. Because the thing that can happen is the next step is to actually disable password authentication completely. So we're going to make it so that passwords just cannot be used at all on this to log into this server. And when we do that, only keys will work. So if we lose the key, we lose access. That would be bad. Don't let that happen to you. So instead of letting that happen to you, what you want to do is you want to actually do this process with SSH Keygen and then SSH copy ID on multiple devices, so that multiple devices have authorized access to it. All right. Now, remembering, you can add as many keys as you want, and you can revoke them as well. And just like I did before, when we nano in there, you can tell them apart by looking at these identifiers on the back end here. Adamant Mammoth, that tells me whose key this is. If I want to revoke this key, I delete that line from the authorized keys file. That has revoked authorization. So anyway, how do we change it to make sure that passwords can't be accepted? So what we do next is we're going to edit sudo nano the /etc/ssh/sshd config file. Now there are a few different things that you should do here, including some stuff for security that is good for a future video. I'll do with a future video, which one would be to change the port number. I'm going to leave it at 22 for now. But further on down, and I mean, there are other things like permit root login. Hell no, I shouldn't do that. Public key authentication, yes, that's actually a default, so it can be left commented out like that. But what we really want to do is deny password authentication. Right, so we can see here, we've got this one here, right? Password authentication, and it's currently set to yes. Right, this yes is a problem. Change to no here to disable tunneled clear text passwords. We definitely don't want passwords to be sent at all. So we're going to go no more password authentication. All right. So if I do that, right, I've written that. Let's see. Okay, so the rest of that file is looking good. There are other things that you can do as well. You can add and allow users and choose who can log in and things like that. But anyway, you got more control. We will get to that in future videos. But for now, what that's done is that's changed the SSHD configuration so that only key authentication is allowed. No more passwords at all, ever. You lose that key, you're done. So now if I go sudo, what I have to do now though, so that that takes effect, systemctl, restart, or just reload actually should work, SSH, right? And I'll just do reload SSH, there we go. All right, so now let's test it out. Okay, I can get in, sure, great, okay, great. Now, in here, let's say I'm just going to rename this ID MV ID E25519 to, I don't know, Fred. Okay, let's do that. We'll rename Fred. I'm not sure if that's going to actually block it. Well, let's try. No, it's still reading Fred. Okay, let's move it completely. Move. Okay, let's move Fred to .. We'll move our private key out of that folder completely. Now let's try it. It's still letting me in. Okay, SSH is remembering where it is. It's yeah, okay, so SSH on this machine is actually remembering where it is. But essentially, wait a minute, let me just go and, right. If my key is revoked, then I won't be able to do anything more on this video. Yeah, I tell you what, let's do that. Boom, I've logged in. I've nanoed nano SSH authorized keys. Let's go in there. Let's revoke my permission. Okay, so I'm about to end the video because I'm going to be locked out of my server very soon. All right, so I've revoked that key. And now if I try to SSH in, whoop, wait a minute, I got to log out first to log back in. SSH in, boom. Now you see I don't, even though my key's not authorized, so what's happened is it says vagrant permission denied public key. Needs to have public key to authenticate. You don't have a public key that works here, so yeah, off with you. No soup for you. You're not logging in. Okay, so that's what it does. In sum, basically SSH key authentication is actually quite awesome because, you know, with this, that means we can use tools like Ansible. We can use a script that will automatically log in, back up the server, do all sorts of maintenance tasks and things like that automatically, and we don't have to enter a password every single time. So, and you can see it's actually pretty secure. There is actually one way that I could get back in is using the vagrant key. But to do that, I got to change directories and things like that. It's a pain. And besides, this video is long enough already. It's almost 30 minutes long. So, at that, in sum, I would just say that, you know, the SSH key-based authentication is the awesomeness. Please make sure that you do it. And remember what Ducky's wingtip of the day said, a machine's private key should never leave that machine. Just generate a new one, and generate a new key for every machine you're going to use. You'll never run out of them. They're free. Just generate as many as you need. And that's it for this video. Thank you very much. Like and subscribe and all that jazz. And I'll see you in the next one where we're going to have a look at what you can do to actually, let's say you have 50 different keys, you can actually get all of those keys to go straight on in real easy with one command. And I'm going to show you how to do that next time. So stay tuned, like, subscribe, do all the good stuff, and I'll catch you next time. Until then, stay secure. Cheers.